Okay, welcome to the second part of the problem. Okay, so if you remember the previous problem, what we did the first part is that we took an example of what is linear momentum, and then we looked at that an engine hits a railway truck whose mass is given to you and it starts moving at a speed of 4.3 meter per second. Then we analyzed the force time graph to get the value of the impulse, and from the impulse we found out what was the Fmax value. This is what we have done so far. Now let us look at the next one, which is again for 8 marks. So I have allotted for 8 minutes. Okay, so after contact with the engine for t equal to 0.4. Now what we'll do is let me write down the diagram. So this is my railway truck. This is my truck, and this is my engine. This is my engine. This is my engine. So when it hits this one here, so what happens? The speed of this truck is seen to be 4.3 meter per second, the maximum one. And after that, what happens? The engine gets decoupled from here, and the truck alone starts moving. Okay, so that's what it says. Truck moves a distance of 15 meters along the track. Along the track, it moves a distance of 15 meters. So this distance is 15 meters, which is given to you. Okay. After traveling this distance, the speed of the truck is 2.8 meters per second. So here it is 2.8 meters per second. So what is happening here? Which means that there is a deceleration being observed, right? Because it's not connected to engine. It has to slow down because of friction. Assuming uniform acceleration, okay, deceleration, that's what it means. Calculate the time it takes to takes the truck to travel 15 meters. What is the time taken for it? This one here. So how do we do this? So what we do is, this is your final velocity, this is your initial velocity over here. See, this is moving with an uniform acceleration. When something moves with an uniform acceleration, you can always use displacement is equal to u plus v divided by 2 multiplied by t. You can use this expression, right? So therefore, what is your u here? 4.3 plus what is v here? V is 2.8 divided by 2 multiplied by t, and what is s here? S is nothing but 15 over here, right? So you can use this. So I can write the value of t to be 15 into 2 divided by, how much is it? 3 plus 8 is 11, 1, 3 plus 4 is 7, 7.1, which should be equal to 30 by 7.1. Now let me use my calculator. Where is my calculator? Calculator is not found. Okay, let me start my calculator once again. Calculator to find out what is the value of this. Okay, now this should be 30 divided by 7.1 will be around 4.22. 4.22. I'm getting it here as 4.22. What is 4.22 here? This is time, so this should be nearly 4.2 seconds, right? The answer we have got here. Okay, now let us move on to the next one over here. What is this now? The time taken by the truck to reduce its velocity from 4.3 to 2.8. We have got this. Next, calculate the average rate at which the kinetic energy. When the moment you say rate, we are calculating something here. We are calculating something here. Then you are going to divide by time. Which time? The time which you have found here, which is 4.2 seconds, right? This value you are going to divide. And what is that you are putting in the numerator? The kinetic energy at which the kinetic energy of truck is dissipated, energy lost, right? So kinetic energy is dissipated means what? Find delta Ke by T. Okay. So what is delta Ke? This should be equal to half m into V2 square minus V square minus U square divided by time taken. Okay. I am retaining this. Why you half mv square minus half mu square is final kinetic energy minus initial kinetic energy. That's what I have done. So which should now be half into, what's the mass of the truck? Mass of the truck was given somewhere here. What is the mass of the truck? It is 2.2 into 10 power 3. Okay, let us take that value. Let me substitute it over here. Half into 2.2 into 10 to the power of 3 into v square. What is v square? What is v square? Final velocity here was 2.8. 2.8. So 2.8. This is 2.8 square minus u square is 4.3 square divided by, what was the time taken? 4.2 over here. Okay. So let us substitute these values once again. Use calculator to find out what is the value of this one. This should be 2.2 star. What I will do is put a bracket here. 2.8 square. 2.8 square minus 4.3 square, and then close the bracket, then divided by 4.2. I get this value. What is it I have calculated? Only this part I have calculated, nothing else. Then divide by 2 once again. Then divide by 2 once again. So you get the answer as 2.789, which is nearly equal to 2.8. 2.8. What is this now? Joules per second. There's a negative over here, minus 2.8 joules per second, but I'm missing something over here. There's a 10 cube over here, right? So multiplied by 10 cube. Now joules per second is watt. So this should be minus 2.8 watt into 10 cube, which should be 2.8 kilowatt, right? 2.8 kilowatt or 2.8 kilowatt. What is the final answer? 2.8 kilowatt. I got this as 2.789. So the answer should fluctuate between, according to marking scheme, it is 2.7 to 2.8 kilowatt is the answer. So it should fluctuate between these two. You will get a correct answer here. Okay, let us move on to the next one. When the speed of the truck is 2.8 meter per second, it collides with a stationary truck of mass 3 into 10 cube. Now what has happened? You had an engine, and then this in turn collided with a truck 1, and this started moving like this, and it collided with another truck 2. Okay. Now the mass of this truck is 3 into 10 cube. The two trucks move off together with the speed VA. So after colliding here, what will happen? Both the trucks T1 and T2 start moving with a common velocity V. Show that the speed V is equal to 1.2. So what is this problem on? There's nothing but your problem on COM, right? Conservation of momentum. No external forces acting, right? So therefore, now what is the mass of this truck? We already said the mass of the truck is, where is it? It is given here. It is just 2.2 into 10 cube. So it is like this has a mass m1. This is moving at a velocity u1, and this has a mass m. This has a this has a mass m1 moving at a velocity u1. This has a mass m2, and this is not moving at any velocity, u2 equal to 0. And what is this now? m1 plus m2. Both of them are moving at a common velocity. Now what should I do? Apply COM. So how do I apply COM? One momentum before collision, right? m1 u1 plus 0 is equal to momentum after collision. What is momentum after collision? It should be m1 plus m2 multiplied by v. So I need to get the value of v. Let us substitute each one of this value. What is m1? 2.2 into 10 cube multiplied by u. What is u? The final velocity 2.8 here, right? 2.8. It was before collision. 2.8 should now be equal to 2.2 plus, what is the mass of the second truck? 3 into 10 cube. 3 into 10 cube into 10 cube into v. 10 cube and 10 cube goes away. So what do I get here? V should be equal to 2.2 into 2.8 divided by 2.2 plus 3 is 5.2. Okay. So let me take my calculator once again. So this should now be 2.2 star 2.8 divided by 5.2. What is the answer? 1.18. I get the answer as 1.18 meter per second. What is it we are supposed to require? We are supposed to get 1.2. See, 1.18 is closer to this, and this is 1.2 meter per second. Wow. Okay. So this we have got the right answer. Okay. So let us move on to the question number 2. We almost completed this in 8 minutes. Thank you.